this video, we're going to talk about fraction division using fraction models and pictures to solve our problems. A model or a picture can sometimes really help when you have a word problem. Like 4 people are splitting 5 candy bars equally. How much do they each get? This does not have to be a beautiful art piece. I'm going to represent my 4 people with 4 little faces. Maybe they don't even all have eyes. So I've got my 4 people. Now I'm going to do 5 candy bars. I like to do rectangles or kind of square-ish shapes because they're easier to divide up than circles. Alright, oh that's 4. I need 5. 5 candy bars. Sometimes a picture is as simple as saying, well, you get this candy bar, and you get this one, and you get this one, and you get this one. Well, I can't just give one person this last candy bar, but I could break it up. I could break it up into 4 equal pieces. Those would each be 1/4 large, because they're 4 equal pieces. And I could give a 4th, and a 4th, and a 4th, and a 4th. So each person gets 1 whole candy bar, and 1/4 of a candy bar. Well, put that together. You have your answer. Without having to tackle any division symbols or anything like that, you can just break it apart with pictures and say each person gets 1 and 1/4 of a candy bar. Done. Maybe it's not a word problem. Maybe you have 3/4. Don't need that extra one. We only want 3 of them. And you're dividing them up into 1/4 size pieces. This can be as simple as saying, how many 1/4 do I have? I have 1, 2, 3. 3/4 divided by 1/4 equals 3, because inside 3/4, how many 1/4 size pieces do I have? I have 3. Here's another one. Now, if this was a traditional algorithm, we'd need to change 7 and 1/4 to an improper fraction. But since I'm just dealing with pictures, I can draw myself a picture. 1, 2, 3, 4, 5, 6, 7. I'm going to draw an 8th one that I cut up into 4 equal pieces. I only want 1 of them. I'm going to cross off the ones I don't want. Okay, well, this is saying divide it into pieces that are the size of a half. Okay, there's 1/2. There's the second one. There's a third one. There's a 4th one. There's a 5th one. There's a 6th one. There's a 7th one. There's an 8th one. 9, 10, 11, 12, 13, 14. Okay, well, I have 14 whole 1/2 size pieces. And then I've got this piece left over. Well, 4ths. How many 4ths are in 1/2? 1/2 is the same as 2/4. So this is the size piece I want. And I'm going to write my remainder as a fraction. How many parts do I have? I have this 1 part. Out of how many parts that I need to make the size I want? Well, I needed 1, 2. So I can write my remainder like that. There are 14 and a half-size pieces in 7 and 1/4. Here are all the whole 1/2 size pieces, and then that 1/4 was half of what I needed to make a half. That's where that half comes in. Let's do another one. Alright, if you don't want to do the standard algorithm, you can draw pictures for all of your problems. 8 and 2/3 divided by a third. I would draw myself 8 holes and an extra hole that I cut up into thirds, and I have 2 of them, so I'm going to cross off the extra one. And I want to break them up into third size pieces. Each of these holes would get cut up into third size pieces. And then I'm going to count. how many 1/3 size pieces are in here? 3. Another 3, another 3, another 3, 3, 6, 9, 12, 15, 18, 21, 24, 25, 26. Our answer here would be 26 wholes because there are 26 whole-sized 1/3 pieces in 8 2/3. Now, if pictures aren't your thing and you would rather say, I'm going to change 8 2/3 into an improper fraction, I would call it, well, let's see. 8 times 3 is 24, plus 2 is 27. No, 26. Keep my denominator, 26/3. One way when you have common denominators is just to say, well, my answer is going to be my dividend numerator divided by my divisor numerator. 26 divided by 1 is 26. So common denominators is another strategy for division. Let's look at that. If I have two different denominators, I can either simplify or multiply and scale up. Let's do the simplifying. 9/12. I can divide them both by the greatest common factor is 3. That simplifies to 3/4. Now I have fourths and fourths. Great. I'm just going to focus on my numerators. 3 divided by 1 is 3 wholes. I think if we draw ourselves a picture of 3/4 and we say how many 1/4 size pieces are there? 1, 2, 3. That's one way to get our final answer. Now, as I was saying earlier, you might not love pictures. Maybe you just want to say that you're going to stick with the standard algorithm. Maybe you don't even want to worry about common denominators. You're just going to use SIRS, which is another video you can watch, and do the same. Do 26/3, the inverse operation, the reciprocal, multiply, simplify, get our final answer. That's another video you can watch. But we do need to know about pictures because sometimes we're going to see a picture and be asked to identify what the problem is. All right, let's look at this picture for example. So we can see that we had a model in blue and it's being divided up in red. So let's start with, what do we have in blue? Well, this is a whole. We're using all of it. There's another whole that we're using all of. Another whole that's 3 wholes plus 3 parts out of 1, 2, 3, 4, 5. So 3/5. So what we're dividing up, our dividend, is 3 wholes and 3/5. We know we're dividing because we're talking this whole unit about division. Well, we're dividing it into groups of how much? Not 1. This 1 represents one group of 1, 2, 3/5. This 1 right here is spanning 1, 2, 3/5. 1, 2, 3/5. Okay, they're all groups of 3/5. That's what we're looking for in size, divided by 3/5. And we can say that our answer is going to be 1, 2, 3, 4, 5, 6 wholes. This is the problem that this picture is representing. And you might be asked to interpret other pictures.